Okay, let's look at practice C. And we'll do number 2 together. Number 2 says a 2,500 kilogram car. So the first thing I'm going to do is I'm going to write my given. And the reason we write the given is it helps us, when we're not sure what to do, how to solve the problem. So the mass is equal to 2,500 kilograms. It's traveling north, and it's slowed down uniformly from initial velocity. So VI is equal to 20 meters per second. By a 6,250 Newton braking force acting opposite of the car's motion. So this is positive. So the force is going to be negative 6,250. Momentum is vector. So we have to be very careful with our signs if something's positive and negative. And again, we're going to use our standard Cartesian sign convention. So it says use the impulse momentum theorem. And the reason it says that is because we can use the equations that we learned earlier to figure this out, but we're going to use what we learned in this chapter to do it. And then the time is equal to 2.50 seconds. So it says, find what is the car's velocity. So that means I want to find VF. How far does the car move? So I want to find X. And then see how long does it take the car to come to a complete stop. So I want to find T when VF is 0, because a complete stop would mean the final velocity is 0. All right, so where do I start? Well, for part A, I want to find VF. So the impulse momentum theorem says that Ft is equal to m delta v. But now delta v is the change in velocity. So I'm going to expand that out and say Ft is m, Vf minus Vi. Now I'm going to look at, well, what do I have here? Where I was given F, I was given T, I was given m, and I was given Vi, so my only unknown is Vf. Now, this is where people make mistakes. They just plug the numbers in, and when you plug numbers in and you don't rearrange it algebraically, that's how you make a mistake. So we're going to just do some basic algebra. So because I want to solve for VF, I want to leave VF by itself, but I also see that VF is, both of these are multiplied times m. So the first thing I might do is, can I divide both sides by m? Yes. So Ft over m is equal to Vf minus Vi. And I'm solving for Vf, so I can add this to both sides. So it'll be Ft over m plus Vi is equal to Vf. So that comes out to be negative 6250 newtons times 2.50 seconds divided by 2,500 kilograms plus 20 meters per second. So we have 6250 times 2.5 divided by, so that comes out to be negative 6.25 plus 20 meters per second. If you didn't make this negative because of this, your answer is going to be completely wrong. So on my calculator, it comes out to be 13.75. But when we round it to two significant figures, we round it out to be 14. Now when we look at our units, remember we're finding VF. So over here I have a bunch of units. So I have a Newton times a second over a kilogram. So I can expand this. A Newton is a kilogram meter per second squared times a second divided by a kilogram. So this cancels with that, this cancels with that, and I end up with meters per second. Is that a correct unit? And then I can add them. I have a meter per second and a meter per second. So this is 14 meters per second. And that's it. Well, it's going in the same direction because it's positive. If it was negative, then the VF would be negative.